Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, I'm gonna show you this like a conundrum or the confusions that you might face when using Sverchok. Um, it's a case of when you have like if you're dealing with, let's say you want to make a 10 points to travel from point A to point B, okay? You can easily in Sverchok kind of make a setup where you're transforming 10 objects using 10 different transform and you end up with 100 different points. That's kind of a, it happens by accidents often. If you're using something like animation nodes, it's probably won't happen like this, but um, yeah, it's just something that's hard to explain. Okay, I'm using Sverchok add-on for a while now, and then I'm trying to move 10 points from A to B, for example. And here's the setup that's actually doing it correctly. I have a single point at position 000, and I have this 10 transform being created by a single stream of time that's being offset by this number, a single number, and then I have this another offset with a range of numbers. Okay, this is when things get slightly confusing sometimes. Okay, I'll use the stethoscope. Okay, I'll break down this setup. I'll show you the kind of like a gotcha. Okay, we have a single stream of time, and then I offset it slightly. And then here I have this another like offset, but this is gonna split the time into 10 different times because this is a range float. See, range float start from 0, stop at 10, and a count of 10. So this is 10 stream of data. Now Sverchok will do like a clever thing. It's gonna split the time. Now the time is running. It's become like a 10 stream of data. You can imagine if it's a fountain and you split it into 10 stream. Okay, that's clear enough. You don't get this in if you're using animation nodes. It's not it's like a different way of thinking. So back to Sverchok, we have 10 different stream of data, and then it comes into, okay, I'm using this map range. I'm just mapping the numbers. So if the stream comes in at different offset of time, I just make the time range, just remap it into different value. Okay, and that's simple enough. Here I'm just offsetting the position in Y using another range float. Originally it looks like this. Okay, that's originally it looks like this. Okay, it looks like see all the points at original position, actually 10 of them, and then they're moving into the destinations at 10 different times, and then 10 different offset, and then they stop, and then we have that effects. You can actually see this if I use the stethoscope. See the value that's changing? It's the X. That's easy to understand, and then I kind of use another number here just for the Y, so we get the effects that we want. Now the problem might happen if you're doing like a, let's say you're using this one. See, like this is a 10 points, and you're thinking, okay, I wanna do the 10 points here with the range float. For the Y, and now you end up with 100 points. This is the first gotcha. Okay, don't, this is the wrong way to do it. So a single points and 10 transform, and you get what you want. This is a correct way to do it. There's a wrong way to do it. This is what I did earlier. So there is other node called vector interpolations, and they're also using 0, 1. These are something that I wish to use at some point to do these 10 points animations, but I'll show you what's going on here. Vector evaluate. Okay, I start with a vector evaluate, and then this is something similar that you might see in animation nodes. Just like a 2 point, and we have it moving from one spot to another spot based on this vector 0 to 1. This is simple enough, and this is actually the first thing that I did earlier, and I did this and I get a wrong result. So 2 points, 2 positions, 0 to 10 in X, controlled by this vector. Okay, now with the vector I want to have 10 stream of data. So I use this time, and then this time offset, and then multiple of data stream, and then with a map range. Okay, everything's ready. Now plug this to the vector, and now we have this. This is actually correct. This is just 10 points, each one of them moving in that direction. Okay, that's easy enough. But now if I'm thinking, okay, this is 10 points, and then I want to use the matrix in, and I want to make it so that 10 points, each one of them kind of stagger. If I use range float in the Y, I have 100 points. This is actually the gotcha. This is the wrong way to do it. If I use the stethoscope and check the data, here is still like 10 data is correct, but here we are multiplying it with 10, and then so we have 100. That's wrong. That's wrong. Okay, if I use list delete and we have 10 data, this is something that I think should work if we actually join it back. So look at this. This is like a single in Sverchok term. If you have like this 2 bracket, and then you have this data, this is kind of the data that's Sverchok likes. Here I'm splitting. I delete the level, so I get this data. So it's like it becomes 10 data. I was expecting that I can kind of split this data into 10 different metrics, so that way I can stagger the points. I think I'm still doing it in the wrong way here. So that's kind of a kind of confusing in itself. So I'm pretty sure this 10 data can be split into different data. So I can, we have 10 points traveling at different time, and I want to split them so that I can just put them in their own transform. And I don't want Sverchok to multiply the data and become 100 data. I want it to do that, just a simple points traveling. If I'm trying to do it using animation nodes, okay, it's slightly simpler. Let's say animate vector. Okay, this is similar to Sverchok evaluate vector. We have start and we have end. Okay, we're gonna end it at x. Okay, from 0, 0, 0, and then the end point is 10, 0, 0, 0. And then we need 10 different points data. This can get confusing as well. Actually, 10 points. I'll start with an object actually. Object transform. I'll start with a cube. Yeah, I didn't prepare this part, but I'm just gonna do it. This is actually really important. So object transform. Okay, object instancer. It's easier with object instancer. Okay, we have a single cube. I'm gonna grab it, make a 10 instance. So we already have 10 objects here, and we're gonna need a loop. And for each loop, I'm gonna use object transform output, plug in the object there, and then with the location here, instead of moving the objects all at the same time from 0 to 10, I'm gonna stagger it. So we need animate, something like animate vector, or we also have a vector mix vector. Mix vector is actually very similar to Sverchok evaluate vector, which is this guy right here. Vector evaluate, 2-point vertices and the vector. Okay, the vector, this should move from 0, 0, 0 to 10, 0, 0, 0, and then the vector will be the time. Plug this guy in. So 0 to 10, we need to clamp it. 0 to 1, it's gonna move from 0, 0, 0 to 10, 0, 0. Okay, cool. That's easy enough. And then we have time frame, and then we need a map range. Time value goes in, input and maximum. Within 20 frames, we're gonna plug this there. And then here we're gonna use frame offset. It's called delay time. We can delay it using the index. So we have that. I'm gonna scale this cube first. So this is just like a Sverchok one. Now let me think. To stagger these points, we're gonna need to use a time. I think vector math will do the job. This is so we're gonna need to combine vector. So the index, it should plug into y, and then this plug into that guy. Now we have that motion. This is actually the result that I wanted. So this is how you do it using animation nodes. Now back to Sverchok. We have vector evaluate, and then we have these 2 points. We have multiple stream of data that are coming in as a vector, and then I want to stagger this data. So if we can do it just like animation nodes, yeah, this actually works just like I wanted. So I'll make it go from 0 to, actually I'll make it from 0 to -10. So animation nodes and SpreadShock. This is in full speed. Animation nodes and SpreadShock. They both have a kind of similarity, but also have, because Sverchok always works with multiple of data. My confusion was if I'm trying to mix the matrix and the vector, and then I end up with 100 different stream of data. That's when things get super confusing for me. Like at some point when I'm thinking, okay, I was thinking, okay, maybe I give like a, instead of 1 point here and 1 point here, let's see if I have like random vector, 10 points of data here and 10 points here with different seed. Plug that in and plug that in. What's gonna happen? See, you see, this is what I don't. This is like a gotcha in Sverchok. Okay, that's exactly what I was talking about. See, this is 10 random points at 10 different positions. And this is also another 10 points at 10 random positions with a random seed. That's why they can travel together. What we end up in Sverchok is often we end up with 100 points. This can be used for our advantage, of course. If we are using the UV connection, we're gonna get this line. Although I might need to do the slicings and splitting and whatnot. But in Spreadshot, it's much easier that when you want to have like a so you have 100 points and you want to trace each point, you know, separately. Spreadshot can do that much easier because it deals with array of data in its own way. But if you want to just animate 10 different points at 10 different times, you can easily end up with 1000 data or 100 of data here. Let's say with a vector here. So I believe we have 10 points, 10 different of data. If I actually use matrices here, matrix in, and I want to have like 10 different time, and it's gonna get super confusing from here. So factor evaluate, and then we have this add that we don't use here. I think in order to make this work and then with something that's easier to understand is to kind of split the data. Split the data here from evaluate points. So if we use list delete level, we're splitting the data into 10. Oh, actually we already have 100 data here. So this is probably not a good idea if we plug in this guy into the vector evaluate. But yeah, of course, 10 data and 10 data here in the vector. We have all 10 points that move at the same time. If you want to stagger it, we don't do it this way. I don't think. Slightly different to way of thinking in in animation nodes. Probably I should have split the data somewhere here, so they kind of stagger, and it's not doing the vectorization. It doesn't. Anyway, the point of this live noding is if we have 10 data and another 10 data, we easily end up with 100 data, and we don't want that. Sometimes we want to kind of, I think, kind of do this in Sverchok, so that we always end up with a 10 data that we can stagger. To make things a little bit more complex is because we are dealing with there's these matrices and the vertices, and if we profile like 10 matrices into 10 data, we get 100 of data. It's kind of multiplying as well unless we split the data. So yeah, that's the conundrum that I was talking about. But if you understand this, it's really powerful. Sverchok is super powerful to do that. With animation nodes, things can be simpler, but when you start to deal with an array of data, it gets really confusing as well in here, and you will start using script node. But with Sverchok, probably You don't need to. There are some parts where Sverchok handles the data in a magical kind of way. It's kind of, yeah, like the Matryoshka thing. So you can handle, Sverchok can handle data that's let's say you have like 8 of data, and then you have 2 data, and then you have 12, and you can kind of put them together in one box, and you can still kind of work with each of data, array of data, and then you put in another box, and another box have like a multiple array of data in different shapes. This is super confusing, okay, but sometimes Sverchok can handle that. Yeah, anyway, that's an interesting case, I guess. It's easy to do this in Spreadshock. Like if you have like 100 points and you just want to evaluate from one position to another position, it's easy. To stagger it is it's quite something else. There must be something that I'm missing here. Maybe I need to split the data somewhere so that it doesn't do the vectorization. But that's the conundrum. Maybe in the next live noding I can explain it better, and then this actually makes more sense. Just be careful when you're mixing this matrix transform and the actual points. If you're working in the points, sometimes it's easier when using transform because you're already splitting the data, separating it into different transform. Sometimes it's easier when you think of it as a single entity, just like a single system of 100 points that's just moving. I guess that's the point. It's a complex thing, I guess. But anyway, I have to talk about it. Anyway, if you have any comments, feedbacks down below, let me know, and I'll see you in the next slide.